now it should be fine. Guys probably couldn't hear me until now. Okay. So before I stopped streaming, because I was sort of sleepy, um, had some work, whatever, a few years back. So you're on this question which I was not able to understand. So they're saying given a linked list and a value x, partition it such that all the nodes less than x come before nodes greater than or equal to x. So let me just hook up my notepad. Okay. Okay. So the problem that I'm having understanding the question is it says given a value x. So do we need to partition it at the third node? No, I don't think so. It means probably means the value x in the list. So all nodes that are less than 3 should come before nodes greater than or equal to x. Basically 2 and 2 which are less than 3 should appear before all the nodes that before nodes greater than or equal to x. Um, so basically find the first node that's greater than x. That will be one of the points in our list that needs to be modified in a way, or let's just keep that as one reference. So everything that is less than this number would come between this number and the number before it, I guess. So I'm just gonna try and write the code for that. Basically what I'm saying is, so we have 1, 4, 3, 2, 5, 2. So we know what our target is. So we find the first node that is less than 3. So we check for 1. 1's not less than 3. We check for 4. 4 is less than 3. So we put our pointer over here. Um, and then we can iterate the rest of the list and look for elements that are less than 3. So is this? Nope. Uh, is this less than 3? Yep. So we move this here essentially. How we do that is we have a reference of this and we check, we set this dot next is this and this dot next is this. And now our pointer points here, the one that's pointing at 1, and we make 3 point to 5. Yeah. So if head is null, return null, and then while head next not equal to null, and head next value is less than our x, save our head. You might have to attach a dummy node as well. Say if the first node is not um, not less than 3. So sorry, show the code. So basically now let's remove this sketch. Um, yeah, let's remove this for a while. Yeah. So we had our dummy point here. Now till dummy dot next was less than 3. We keep moving forward. So right now it's true. Now dummy points here. And now dummy dot next is greater than 3. So now we stop here. So we will be appending to this node now, our D node. What's this? What's like a faded color? Okay, so now we have to find all the elements that are smaller than our target and then push them between D and D next. Yeah. So let's take a while now pointer is right now at 4. So if ptr value is less than x, actually next value is less than So right now, that's not true. We update ptr. Now since this is true, 2 is less than 3, we set we save this target. So auto temp equal to ptr next. Then we point 3 to 5. So ptr next equal to temp next. Now we make this point towards this. So temp next equal to dummy next. Now we make dummy point towards this. So dummy next equal to temp. And after that, we move pointer forward. Let's check in the last case. So is pointer dot next null? Is pointer dot next null? If it is null, we're at the last value, which means if the last value needs to be shifted, sorry, it'll already be checked when you're over here, right? When ptr is actually at 2, at this 2, is going to be checking if this value of 5 is correct or not. So at the second last point only it will check. Alright, so we can return our root next, which was our dummy plus 1. Seems fine. Not a lot of ifs and all. Clean code essentially. Seemed to work, but I mean my logic was based on the example. I might have understood the question wrong. Hmm. Oh, what if so this sort of fails because we move it forward. Hmm. That actually failed because we stopped checking. We didn't check for the last case because say my pointer was in 3, then we shifted 1, and then we shifted our pointer to 3 dot next, which is 2. So now we didn't do anything. Why is this a problem? Oh, they should maintain the relative order. Sorry. Okay, so let's just write this example down and see where it went wrong and what condition could we add or modify to get this right. So our input was 3, 1, 2. We created a dummy at the start. Oh, yeah, we added a dummy at the start and pointer is dummy dot next. Oh, sorry. While dummy dot next dot value is less than x. So since dummy dot next dot value at the start itself is not less than x, we don't move anything, and our pointer points here. Um, After that, we while pointer dot next is not null, if the next number's value is less than x, which it is, sec, then temp is pointer dot next. So this is our temp pointer dot next equals temp dot next. So this points here now. So remove this one for clarity. Then temp next is dummy next. Sorry, what? Oh yeah, sorry. Sorry. So this points towards this now. It was pointing here earlier. So now this connection is gone. And dummy dot next points towards temp. Dummy dot next. This points towards this. Sorry, temp is pointer dot. Oh, dummy dot next. Dummy dot next points towards. Oh, so now this points here. So our flow becomes dummy to 1 to 3 to 2. So let's rewrite that while pointer is at 3. So I think we said dummy dot 1 to 3 to 2, and our pointer was here. Now if we move pointer ahead, in this case, we are skipping the checking of 2 itself in a case where we updated it. So let's add this else back and see what happens in case of the else. So now this should be moved again. Oh, actually, do we need to update dummy? Do we ever need to update the dummy? Yeah, the else failed because we didn't move the dummy ahead. Uh, Actually, we need to update the dummy to temp. Isn't that right? What is the pointer that we move? It's dummy, right? Yeah, so I guess dummy is dummy dot next. We didn't write that anywhere. Because, yeah. So this was dummy. Our the one was dummy dot next. So now all the elements that we add have to start from our next element. So in our earlier case where say we had 4 and 1, so when we pushed 4 between 1 and 3, we our D was pointing at 4. If you remember, you can rewind and check. So now we need to point D at 1 so that they're added in order. The next number that you're adding should be added after 1. So this wasn't really hard, I guess. Not sure. We'll not look at the solution today. I usually get overwhelmed and I just want to have a good session today. So subsets 2. Given a collection, return all possible subsets. The solution set must not contain duplicate subsets. Must not contain duplicate subsets. Okay. which the input contains duplicates. So I think the condition earlier in one of a similar question like these, where we had to make some sort of sets with the input without having duplicates, was um, if I remember it word to word, it was if I equals begin or nums I is not equal to nums I minus 1, then we did then we added the set. In that case, in those cases, I think we were given a target size, so we added the condition for the target size, whereas let me see, was permutations probably. Hmm. So if I equals beginning or num input I not equal to input I minus 1. So if we just use that earlier logic without using our brains, this would be the code for that, and seems like it has worked correctly, but has failed somewhere else. 4 4 4 4 4 4 4. Oh, sorry, we had to sort it also. So sort nums dot begin, comma nums dot end. Yeah, this was sorted as you see. So nothing to this, I guess. If you've already seen how this was generated from this, we had like a really long discussion. It was really confusing in the beginning, and then we worked through it case by case, example by example. And we finally figured out why it was happening. So, all right. So, yeah, good. At least we remember the condition, even if you have to do it by memory next time. Okay. So, problem number 92. Okay, it says reverse linked list from a position M to N, do it in one pass. M to N. Okay, so you just iterate M minus 1 times and then you iterate N times. So you switch everything. And then you make your M minus 2th node point um, to your nth node. Okay, so let me just write it down. Basically, let's take the example on the board and see if we can quickly explain it. So we have 1, 2, 3, 4, 5. So from 2 to 4, they say flip it. So if we iterate just once, so if we iterate m minus 2 times, we won't be able to solve it for m1. So we can't do that. Instead, what we do is we have learned something is to attach a dummy pointer. So we attach the dummy pointer here, and from the dummy pointer we go m minus 2 times. So we save this node and we save this node. Um, we save this node because this is we're gonna set the next of this to this one, and we will need to have a reference to our last node as well, as we're going to set 2 dot next to that value. So yeah, so we have this pointer and we have this pointer. Now we know how to reverse a linked list. Just store this, uh, make this point to the previous node, this one, and this node, the 2, and make the 3 point to the previous node, and store this as the previous node, and then this is the next node before you do this, I guess. Yeah. Next or current, whatever you want to call it. So either you name it previous and next, or previous and current. So we create a dummy initially, new list node with any value. Sorry, not min and max, int min. Yeah, and then you make dummy next equals head. Now you can store auto root is dummy. So we'll return dummy dot next, whatever that will be. Now uh, m minus minus, and while actually if you do minus minus m, then it only runs once, right? So while minus minus m dummy equals dummy next. So that, oh sorry, is the code visible? Yeah. So now let's just clear the board a bit. Um, see what is necessary and what is not. Yeah, okay, even this is not necessary. So now let's just call this D. Now dummy points here. Now we save a reference to our current node, which is the um, say final head is the dummy. So I mean, it's not really head, it's the uh, get back value, the one that you have to point to in the end. Oh, sorry, the one that you set the next to. Um, so set next for this value. Now we reverse while minus minus n minus m. Oh, sorry, while uh, n equals n minus m, while minus minus n. So basically to move two nodes, right? Mm. So it'd be n minus minus or minus minus n. So if n is 2, then we are moving 2 points. Okay. So let's set our current and previous and such. Auto current equals dummy dot next and auto previous equals dummy. So now this is our previous node and this is our current node. So auto temp is, so we store the reference to our next number, which is current dot next. Then we update our current to point to the previous node. Then the current node becomes the next node of current, and the sorry, so this happens before. Now the previous node points to previous pointer points to the current pointer, current points to temp. So let's actually go through with our example. So we set temp as current dot next. So this is our temp. Now current dot next becomes previous. So you update this, and this points to now 1. And then we have to set temp dot next to current. We can't right now. Yeah, not right now, sorry. So we set current dot next previous, and now we set previous as current. So P now points over here, sorry, over here, and set current equal to temp. So current now points here. Now the next time temp is current dot next, so temp becomes this one. Current dot next is previous, so 3 points here. Let's write it in a way that is actually in the end result. And then current dot next is previous, previous is current, and current is temp. So this goes like this, and this goes like this. Um, and this link is removed. So in the end, what we can do is if temp is not equal to null, which it shouldn't be, uh, we can set the temp, set the current next as previous. Now our temp.next is what is the node that we need to store, the one that will be pointed to by our old lists end, so to say. We'll also store auto set to point last, sorry, uh, point end as dummy. Next, there'll be a lot of corner cases that will fail in this code, but let's forget about that. Auto last is temp next. So now let's update our pointers. So our dummy, which was 1, should point to the temp. 1 points to 4, right? Cool. Now, and 2, uh, and 2, the one that we moved, points to last. And then we return root dot next. So this should run for this example. Temp was not declared. Just use current here. And now let's check it for a slightly different example where we do reach the end of our array, and it worked for that as well. Or did it? It did, and let's see what happens if we start from the start. This should also work. Awesome, because we used the dummy, so yeah, this looks fine. I've submitted it, and it has successfully run, so our logic was right. We might have handled a test case or two extra. I don't think so. This is how the iterative reversal works, as far as I remember. Just had to update the last nodes and then the resetting values. Cool. Okay, I've done this question before. If you want to see, it's not doesn't have a great up rating. So it says that given a string of digits, restore it by returning all possible valid IP addresses. So all you have to do is check if the number that you found picking up 0, 1 or 3 digits is valid IP number that is between 0 and 255, then you can pick that up and put a dot next to it, or else you can't, and then you just return. If you want me to post that answer here, I will, but it's really not worth doing this question. It is a backtracking question as far as I remember. And permutations, palindrome. Or was it greedy maybe? This is a good question. Distribute candy. I like this question. I couldn't think of why this was the correct logic, actually. I think this was also a good question. The seeds was also a good question, but it was sort of maths. I'm not able to find IP address. Restore IP. Oh, it was strings. Right. Yeah, same question literally. So, you want me to go through this? Helper function. So DL is the number of dots left, full stops. So if dots left are more than 0 and you've already reached, and like, so I didn't use the indices, I updated the array, this rem, where I removed one character, I think, from the string. I think so, yeah. Where did I remove it though? Oh yeah, not substring. So yeah, if you don't have any characters remaining, you still have dots, which means you've already lost. If you have used all characters and dots and your last character was not a dot, then that's one of your possible answers. You push it back. If ln, what is ln? Okay, yeah, so if your characters is 0 and if you've not used any dots yet, then just exit. Uh, Sorry, if you don't have any dots left, then just exit because you just checked for. So the problem is that you can't have this sort of a answer. Let me see. See, the numbers cannot be 0 prefixed unless they're 0. So this was something like if you have a, I'm not sure if it will do, yeah, sorry. So if you have a 0 and you find another 0, then this is not allowed. So if ln is 0 and you don't have any dots left, the last number was a 0 and you don't have any dots left, you exit. Don't know why, because you have could have something like 10, 10, 10, then you had 1 and then 6. Oh, is it a 0? Yeah. And do you have any dots left? Yeah. I mean, no. So exit. What? Okay, I can't remember what this case is. Um, so this code might break in here because they have better test cases. Um, let's call this read code is better test cases. Yeah, and then if the last character is a dot, then you add the next remaining number and recursively call the function. And if the last character is a number greater than 0, then you check if your answer, if adding that number, um, oh, last number is actually the last digit that you added. Okay. So yeah, because if it's a 0, then you can only add a dot to it. You can't add another digit to it. So if it's a dot, if it's a 0, if you don't have dots left, then you return. Otherwise, you add a dot. Yeah. So if adding the next number makes it less than, is less than, gives it, is makes that number less than 256, then you're fine. Take that, update the last number, and call your helper function. If you don't have any dots left, um, then you exit, else you add a dot without including the number. So this is the case for not including the number. This, yeah, that's it. So A was not declared in this scope. Of course, A was not declared, mate. So this would work probably for obviously the default case that was given in IB as well. We're just marking this question. If A equals, if A dot size equals 0, return red. Pretty sure now that's the only case that was extra by leetcode. Okay. So yeah, the solution really. Uh, Straightforward backtracking, I think. Let's see what people have done. Hmm. I don't think this is great. Anyway, yeah, I guess this is fine. There are some extra cases like if have there a number of dots used? Start, step. Hmm. Okay. Mm, got it just once. Hmm. Okay. Oh. Using a for loop. Okay. Just a little different, I guess. So if you use too many dots and the number of remaining characters is too many, then exit midway. Okay, given a binary tree, return the in-order traversal of the node's value. I don't even know why they've asked this question. So left, center, right. What? Reverse revision table. Could you do it iteratively? Oh, iteratively. Okay, so that's the trick here. Hmm. So basically iterative DFS. So we do have difficulty in doing. So basically DFS is like thinking of backtracking, and we have done some parts of backtracking recursively, iteratively as well, where we've used a for loop instead of a just our backtracking functions. So hmm, in order traversal. Okay, so let's try write something down to see if it makes sense. Um, okay. Hmm. So let's say you're at a node. We could do something like, so maybe we have to do it iteratively. I mean, so the one of the three traversals that we know is that is iterative is BFS. So which maintain a queue, uh, and but in that the order is either top to, it's like level by level, but it's not left, center, left, root, right. So maybe what we need to do is insert during BFS in a different way. Hmm. So we'll have to, of course, include our root in our queue, and then while our queue is not empty, while it's not empty, um, uh, hmm, hmm. Okay, I'm gonna take a minute to think about it. I'm not able to just come up with something. Hmm. So say if we push to our queue the left node, and then we push our right node as well. So now when we come out of our while for the first time and then go back to the top, we take the left node and say if we empty the queue for a while and then take the left node and the right node, push that to the queue, and then you push back the right node that you initially had. So now our queue will contain root left, then its left and right, but but the issue with this is what is in order? It is center left right, right? Yeah, so center left right we can do that. If we push our left and right in an empty queue and push the remaining queue after our after adding the new entries. So what we actually just needed was to push somehow to the right places. And actually checking during the time of checking, we actually only need to push always in the start, because whichever node you visit, we need to visit its left and right first. Okay. That makes sense. So let's make a queue. One sec. I, yeah. So we have our return value, our queue. We push the root in the queue, and while the queue is not empty, we will push the. Okay, so you take the top element, auto tp equals q dot top, q dot back actually, and oh, not back, sorry, q dot front, yeah, and then q dot pop. Then we add tp dot value in our return list, and we make another queue. Let's call it temp. Uh, and then temp dot push. If tp left not equal to null, temp dot push. What's your problem, mate? Sorry. Tree node star temp dot push tp left, and if tp right is not null, temp dot push tp right, and temp dot, we have something like add What is emplace? Hmm. Okay, merging queues. So obviously the simplest way is while queue, while not queue dot empty. Um, Sorry, so I pushed left and right node and yes, while queue is not empty, I will take another item from the front and pop it and push it in my temp. Auto top temp dot push. Sorry, I'm pressing the wrong key again. Temp dot push top and then q equals top. Sorry, temp. And we have to run, yeah, return red. Output 1, 2, 3, expected 1, 3, 2. So we took 1, put it in our list. Does it have a left? Nope. Does it have a right? Yep. Push it in temp. And then whatever's in the queue, push into temp and then set q equal to temp. So now q should be 2. Q should have 2, right? So now output is 2. Is in order something else, guys? Is it left, center, right? Then this is not gonna work. Left versus the root, then finally right. Oh, so if a node actually has a left, if a node has a left tree, so actually take the front. Uh, if it has a left, then you can't process this node essentially. Then you need to push. Then you need to push your left node before you need your left node before your current node itself. Q dot q equal to temp, you continue. If it has a left node, okay, nothing. If it doesn't, you pop one, then you push two. Okay, let's put a debugger and see. I think that's gonna be quicker than analyzing it like that. Okay, let's play. So Q is 2, 3. Red is 1. Temp is, doesn't matter what temp is. Okay, TP is, what? TP is, oh, okay. So TP has is 2 and left is 3. So if it has 3, then you create a temporary list. You add the left to your list, and while the queue is not empty, you pop from the front of the queue. So you popped, what's in the queue? 2, right? And you push that to temp. So now temp is 3, comma 2. So I'm processing 2 again and again, again and again and again. And I can actually, so I can just clear TP left is now null. Because I don't have to process it again. So this does have some code repetition, so I'm not sure if this is if root is null and shift home, control X, back, delete, down, enter, return, I don't know what, blank. Okay, this should have worked. Awesome, worked perfectly. But let's see some other solutions. I think this is the last question of the stream for now. It's been an hour. Hope you guys enjoyed the stream. 3 methods to solve. Oh, so it says while stack's not empty, you push it into the stack and set the left to null. Oh yeah, so you used stack. Then else push the current node. Pop. If right is not null, then you push the right. So stack is not empty. If the current node has a left node, push that. Ah. So for every node, you push the leftmost node, and in the end, you will at the top you'll have the leftmost node. So you use that, pop it. Now, if the node, which node? If the top node has a right, then you push that. Then his left is processed, and so on and so forth. If not, then you come out to parent to a node which does not have a left anymore, which will be all these nodes. Hmm, this is better. Uh, I was thinking of either queues or stacks. I used queue because I was planning on doing this, but I think their method is also pretty neat. Um, I didn't think in the direction of stacks. Maybe if I had, I would have probably gotten that solution as well. So using stacks is better because once you stacked a left node in, when you take it out, so you stack the last left node last, and when you take that out, you check for its right, and then for its right, you'll check first. So whichever node you put in right now, you'll be checking for that, which is something like that we wanted in our queue, so we had to change our queue. But still not bad, decent runtime. Okay, so we solved till 94 today. We've done about 109 questions. A bit slow in the last few days since um, I went out on Friday and I couldn't give it time Friday, Saturday. Um, Still have Sunday left, the entirety. So we will try and get through till 113 perhaps. Yeah, long way to go. Uh, Probably after I am done with, say, about when this ratio is about 1 is to 3, so like 75% medium, I think that's when I might switch to hard. Although I don't think, like, actually not hard. Let's switch to exploring past interview questions. Yeah, because sort of our goal here is to, you know, get through an interview in the end. Also to learn something. I think it's been more fun for me to learn this than it had ever been before, especially during college, which is when I didn't study. Yeah, it's been fun. I hope you guys are having fun as well following. So yeah, 95 to 113 is our goal for Sunday, and then we start questions. Oh no, wait, that was after 75. Yeah, sorry. So yeah, goal for tomorrow is goal for Sunday is 3, 6, 8, another 8 questions, of which few might be skipped because of their quality or such. All right, see you guys later. Bye.